Are we gonna actually play?
Yeah, but
I know, I'm doing the same thing.
it's not even
So,
spinning.
complaining.
That's very good.
Okay, I think we're recording now. All right, let me walk through 72 from the homework. 72, and then we're also going to look at something today related to harmonic motion, which is kind of cool. These are things where it's not like you're having to memorize how to write a function like this, but if I give you a function written like this, you should be able to pick out the key details and be able to use that formula to find different values. Okay, so for example, in this one, as you look at the function that we're given, this is our sales of seasonal items. Okay, so evidently they're winter seasonal items. So, as you look at this, you'll notice a couple of things. This is our D value, 74.5. 43.75 is our A. And then you see here the pi over 6 is B. Okay?
So they use t instead of x.
They use t instead of x because they are writing this function of sales over time. Okay? So as you look at these different things, D relates to a vertical translation. It's up 74.5. Okay? Now, that D, remember we talked about the midline of your sine curve? That D is always going to be your midline. Okay? Then, the amplitude is A, so that's 43.75. So you'll notice I went up 43.75 from the 74.5. So our highest we're going to go is 118.25. The lowest we're going to go is 74.5 minus the 43.75. And we get down to 30.75. Okay.
So we use 74.5 to plus 43 to get the.
Yes. We add 43.75 and then we subtract 43.75. Okay. Now, you'll notice I already sketched the points. Cosine starts at the top of the amplitude, and then we have the 0, which is now up here at 74.5. Then it goes down to the bottom of the amplitude, then back up to the midline, then up to the top. Okay? The only thing we need to do is label these x coordinates along the bottom, and for that we need the period. Okay? So you'll notice here, the period is always 2 pi over b. This is something you ought to know. Okay? The period is 2 pi over b. We identified b as pi over 6, so that gives us a period of 12, which if you think about the situation, it makes sense, right? We're talking about time in terms of months, and we're looking at a full year. Okay? So you'll notice along the bottom, I labeled it 3, 6, 9, and 12 for the 5 points. 0, 3, 6, 9, and 12. Okay? Now, the one thing that's a little confusing about this is they said t equals 1 corresponds to January. Alright? You could think of that as the end of January. So like from 0 to 1 would be the month of January.
Yeah.
And then from 1 to 2 would be the month of February. So here, we go from 11 to 12 would be the month of December. Okay? And you'll notice here we're at our peak in December and the beginning of January. End of December, beginning of January is when we're at our peak, which makes sense if these are seasonal items. Okay? So,
In June, the
And-
lease sales.
yeah, in June, month 6, we have our least number of sales.
I would think
Okay.
it wouldn't be as curvy. I think it would be more like,
Yeah.
not as curvy.
Yeah, may not be
More like-
quite as curvy as this, but
right after like October.
Yeah. Now, if we were talking about, I don't know, camping gear instead of winter seasonal items,
The opposite.
this would probably be reflected, you know? To where the min points were in the winter and the max points were in June, so, yes.
And it wouldn't matter if, say, they used it with sign, right?
Yeah, if they had used sign, there would just be a horizontal shift most likely. Cause sign would start here and then go up to here, then down to here, then down to here and up to here. This would be the sine curve. Okay, so it's just shifted over.
Why they using the cosines that are not using the sine?
That's just what they picked.
Oh,
That's the cool thing about sine cosine. You could pick either one.
So sine would just be translated to the left, right?
Yeah, if we wanted to do this, we would translate it to the left.
So at 0, it's gonna be at the top.
Yeah.
Alright.
Okay.
At 12 again. At 0 and then 12.
Yeah. Any questions about what we've done here? Okay. If we wanted to find the time when it hit a certain amount of sales, how would we do that?
Plug in for X or T.
Okay, we'd have to plug in we'd try to find T. What if we wanted to find the T for when we were at, say, 100?
So you're plugging 100 on S.
100 equals.
S. Yeah.
So can't you just?
Yeah, 100 would be S, so
In the calculator, just put Y equals 100.
there we go. If we're using our calculator, you can graph this and then graph the line y equals 100. And right there we're gonna have 100, and right there we're gonna have 100, so you find the intersection points, right?
why is 100?
I just threw that out there. I said, what if we wanted to find when the sales hit 100? Okay, yes?
So there's not a test that asks like where until they're 100, do you put both points or just take one?
I'd probably say when's the first time it hit 100, or I would say when are the times plural.
Are we
Okay.
gonna do a question like that?
And
on
that-
this?
That's the kind of thing that a company might do. For example, a lot of stores are hiring extra workers. We might know, hey, our normal staff can handle it as long as the sales are below this amount. So what's the time frame that I need to hire extra workers for? Okay. My sister-in-law's just picked up a little side job working at the mall by the little store, just for some extra gift money. And she's only gonna work there for like a month or two. But that's what stores do. They'll pick up some extra workers for these times here when the sales are too high for their regular staff to be able to handle it. Okay. You think of other seasonal type of work, they kind of do the same stuff, you know. Well, down here it's a little different because it's always warm, but you know, up in Ohio, landscapers lay off half their staff or more than half their staff every end of September, you know, and then all the snowplow companies hire them. So, but anyways, that's what some of the stuff can be used. What were you gonna ask? I'm sorry.
If we're gonna have a question like this on the test.
You might see something like this where I give you will see something like this where I give you a function and ask you to use it. Okay. And really it's understanding what the parts of the function are and then being able to, you know, plug things in and figure out. So, any other questions from that homework?
Oh yeah, 77.
77, is that
And can I know the answers for 84 and 86?
84 and 86? Which page was this again? 305. Okay. 84 was A and 86 was D. Alright, so 77. Here we're looking at the phases of the moon. So when we have a new moon, we're looking at that as being 0%. lit, and a full moon, the entire moon would be lit, so that's 100%. Okay, so putting a scatter plot together, you could do that. You could do that on your calculator. If you go to stat plot, you can actually put in values. But we'll kind of skip A and go to B here. We want to find a trig model for the data. Okay, this one, if you remember, we said to use the highest point and lowest point. Well, here we have the highest point and lowest point kind of repeated a few times. So what I would do, I mean, the highest point is this one clearly. That would be a full moon. The first time the lowest point comes into play is right here at day 29. So you could use that, or you could use day 59. It doesn't make a difference in this case. They're both 15 days difference. Okay, so if we use this, we said we could actually figure out from this both the amplitude and the period. Okay, now they didn't say whether we had to use sine or cosine, so let's just, since it starts at 0, let's go ahead and use sine.
The answer wasn't sine. I tried to use cosine.
Okay, it actually wouldn't make a difference. The only difference would be in your value of c, because here, if you used cosine, you would be starting it over here at day 44, so you'd be translating it over 44. If you were using sine, you would only translate it over to 29. Okay, so the process will be the same. How many of you did use cosine? If you tried it, how many of you use sine? Okay. Alright. Since this starts at 0, I'm just going to use sine. So here's day 29, and the percent is 0.
Well, shouldn't
Okay, actually, yeah, we're going to use a half. So day 36 is really the one we're going to focus in on.
wouldn't 29 be below the x-axis?
Well, y is 0. So we're actually right on the x-axis there. At day 44, we're up at
Oh,
1.
right. Okay, my bad.
Okay,
I was adjusting the graph to.
What are you doing?
yeah, that's alright. So here's the bottom of our sine curve, here's the top of our sine curve. Halfway between 29 and 44 would be, 35 and a half.
That'd be
Okay.
roughly.
And that would be at 0.5. Okay? So, more than likely what we'd have is we'd just have 2 days where we had that half moon, or 2 nights, or an even number of nights, or something like that. But you can see here, we found day 36, so probably day 35 and 36. But to be, with our graph here, we have the 35.5. Now, that, like I said, we can find the period and the amplitude for. What would the period be in this case?
No. It's 30.
30.
29
Here's 15 days, right? And how much of the period is that? Half. Okay, if I drew the other half to go up to day 59, here's day 52, here's day 59, I'm getting back down to the 0. And even though that's not how we typically see the sine curve, that is one full period of a sine curve. Okay?
That makes sense too, because it's a moon, right? So
Yeah, and the phases of the moon do repeat every 30 days. That's why a lot of ancient calendars were based on a 30-day month. Until Julius Caesar, in the 1st century, came up with the Julian calendar we use today.
the world history.
There's your trivia for today.
How come we have
Okay.
31?
What?
Because
Make the,
because it gets to 365 days a year, so
Yeah.
30
Yeah, but how do we know that there's 365 days a year? What
days
It's
or
actually-
something
it's
we
actually-
made up.
They figured it out mathematically.
It's actually a little less, but you
So.
can't do like
That's why we have a leap year.
Anyways,
4 hours.
We've got a lot to do. You can
23
ask your science
That's why
teacher
we have.
that stuff.
That's why we leave it.
Alright, so our period's 30 days. Okay? 30 days. And what's our amplitude?
One.
1/2.
Yeah, it's 1/2.
Um,
Because from our midline, we're going up a half and down a half. Okay?
Translation.
We do need a horizontal translation.
Should we like work backwards to see the
-29.
Well, here's the deal. We need to figure out where that starting point would be, and that's why I figured out this 35.5. Okay? If we're using sine, then it's going to be 35.5. If we use cosine, we can use the 29 and reflect it, or we can use the 44 and just leave it a positive cosine. You actually have a number of different possibilities here. Okay.
Where do we get the 35.5 from between the 29 and 44?
Yeah, I averaged the 29 and 44. Now, maybe to avoid the fractions, we ought to just use a cosine. Okay, so let's go ahead and do that. And to avoid having to mess around with negatives, let's go ahead and make our translation all the way over here to day 44. Okay? So the horizontal shift is 44. Okay?
so that's C over B, right?
The horizontal shift is always C over B. Yep. The horizontal shift always equals C over B. Okay? B, we need to figure out first though, because the period always equals what?
2 pi over B.
2 pi over B. These are two things you ought to know. Okay?
So it's negative
So-
pi over 15.
Yeah, 2 pi divided by 30. Our period is pi over 15. Okay?
And, well, B is pi over 15.
Yeah. Oh, yeah. Sorry. 2 pi over B. Yeah. B is pi over 15. Okay? Then we can find C now that we know what B is. Okay? The horizontal shift we're saying is 44 because we're going to use cosine. So 44 equals C divided by pi over 15.
44 pi over 15. Which is about 3 pi. Like,
Yeah, 44 pi over 15 equals C. And we don't have to get fancy with or anything, we can just leave it like that. Okay? Is there a vertical shift?
yes.
Yes.
Plus
Yes.
0.5.
Yeah, it's up 0.5.
So A is
Okay. D is 0.5. A was also 0.5. Okay. So now when we put everything together here, we have y equals D plus A cosine of bx,
Which is 40.
so pi x over 15, minus c. Good. 44 pi over 15. And that's it. Okay. By the way, one other way, essentially what happens if you notice every time here, C equals B times the horizontal shift. Okay? if you're given the equation, you're trying to figure out how to sketch it, this is helpful. The shift equals C over B. But if you're trying to figure out what C is, it's always going to be B times the horizontal shift. Alright, so that's just, obviously you can do the algebra, but, okay? Yes, sir.
I don't know how to do E.
How would we do E? We got the period. Our model fits the data pretty well. Estimate the percent illumination of the moon on June 29th, 2007. Okay? So let's think through let's look at our problem again. This is day X of the year 2006. Okay?
So that's 365 plus X. Well,
I don't
So,
know what day of the month that they started.
so what day of the year is June 29th?
No,
well,
look,
yeah, that's.
Isn't it just the 29th of January? Isn't it this? Because since it repeats every month, isn't it the same corresponding?
It's 365 plus
days.
29.
No, but
It
it's
repeats every 30 days.
Yeah, but-
Oh,
Not
is it-
necessarily, yeah, that's what's a little tricky.
no, but it also says. Can you go up to the question, please?
Mm-hmm.
X equals 540.
It says it's. Oh. Okay, X equals January 1st.
So you just
Yeah, of 2006. So
So X equals
we
540
need 365.
plus.
Here's what we're gonna do. We need to plug in for X. I think you guys
Yeah.
know that. We're plugging in a date. So X equals 365 plus
29.
January plus February plus March, which is 31, plus April plus May plus 29 days of June.
It's 540.
Do you need to start at 365, or can't you just act as if it's 2007? Because if it's 300,
Well, again, it's 30 days, not months.
but
See, that's the thing. Our model is based off of 0 being January 1st, 2006. So you can't just say that's going to be the same for every year. I mean, it'll be really, really close, but
It'll get off sooner.
and yeah, the further you get away from that, like if we tried it for 2014, we may be really off. Okay.
You calculate that for that. So do this one.
So we figured that all out.
540.
540. So now we plug in 540 for X. Make sure your calculator's in radians. Okay. And then just figure out the value of Y there.
I got 345, 545,
Check that in a second.
160 plus.
And how do we know it's a unique?
Yeah, it's something flat. It's something flat.
Oh, I did not get that. I got a really small decimal.
It's just
No, but I got, for X, I didn't get 540.
No, it has to be something flat.
I got 545 for X.
Because the last numbers are something flat.
So here's your 65.
all right. So what do we get?
Wait. It's 545, X equals 545.
All X was 545.
Yeah.
How do you switch your calculator?
It's already.
Click mode.
Do you have 83?
84.
Yeah, click
84?
mode, and then if you scroll down, it should say
Yeah,
radian.
45.
My bad.
It should be like in the
Nice.
black.
Can you find it?
45.
45.
They're pressing it.
It's a huge rate.
You want it?
All right.
Okay. No problem.
Binta
Because he's late, would you want one?
I would want
Binta
one.
smaller if you want. Binta.
Oh.
Binta.
Sure.
Binta smaller.
Oh, there you go.
Binta smaller.
Oh, thank you.
I'll pinch this.
Sorry.
Binta
thank you.
smaller. Binta smaller.
You can take it for your class, actually.
Binta,
Binta.
yes.
Yeah.
Oh.
See, I brought you a present this week.
Well, thank you.
This is a bad part though. I forgot to write my name there, and I accidentally signed there, and my teacher signed under me.
Okay. Tell you what,
Okay.
we'll dig into that
But it's gonna pick
in a few minutes
If
here.
you want, I can have him email you. Okay.
She doesn't work, she's on work, she's a manager.
Yeah. We got it if you wanna.
What is that?
All right. So what'd you guys end up getting?
0.345.
Yo, so what about the cupcakes though? Yeah, what those
Okay. So you got Y equal to 0.3 what?
45.
Alright, that's probably good enough.
Wait, I know, Summer's done.
Alright, so we're at 34.5%. Did anyone look at the graph? Do we know if that's on the way up or on the way down?
it should be on the way up.
Here, I can plug it in. Well,
Yeah, let's take a look at the graph just to see. Because basically, here's what we've got. Here's our moon, and we've got about this much, or maybe about this much that's actually lit. Okay? Which means we're a little over half dark.
It's going down.
It's going down at that time.
Yeah.
So we would call that a waning, because it's getting darker, right? And it's only that much light, so that would be a waning, maybe a waning crescent. Maybe it's still in the gibbous stage.
I think it's hard.
Gibbous is just a little bit more than half. So,
How many nights of full moon is there in a month? One, right? One or two?
exactly full, I think it's just one, but
Just one.
it looks pretty much full.
Maybe three even more.
There's your word of the day, gibbous.
Yes.
That's when it's a little over half full or a little over half dark. Anyways. Alright, we'll give you guys some opportunity, we'll give you some opportunity to look at some more later if you need. But I want to look at some applications here.
Gosh, my hand.
Yeah.
It's on the way up.
Okay.
I don't know.
It's on the way up?
I think I did it wrong, but
It's on the way up, well then it would be called a waxing,
yeah.
or no, yeah, waxing, it'd be a waxing crescent, or something like that.
Yeah, it was just.
Okay. So, anyways, what I want to look at to finish off our chapter, this is really the last section we're going to look at, but it's applications and models using trig functions, and there's three basic kind of categories of these problems that I want to look at. And the nice thing is one of those is already, we kind of just dealt with a little bit already, but we're going to look at one kind of cool application of it. But I want to talk about two terms here. They're names for angles. Okay? We have the angle of elevation and the angle of depression. And one thing that's significant to recognize here is that in any given situation, these terms are really just a matter of perspective. Where are you? Okay, because both of them have to do with a horizontal, and basically we have one thing that's above another, and we're measuring the angle to get from one to the other. So you can either measure up from the bottom one, from the horizontal up to the other one, or if you're on the top here, you can measure an angle of depression downward, okay?
I always hated these, the teacher make you like draw whatever it was. There's like, if it was an airplane, you have to draw an airplane.
I love
Yeah.
that. It could be other things
Well, I like to, I'll usually use, like, as an example, you could use, here's Romeo, and here,
I hate drawing. I know.
here's the balcony, and here's Juliet.
so bad.
Okay. And they're looking at each other, and you see here, okay, an angle of elevation as he looks up, an angle of depression as she looks down. Alright, and realizes she's doomed, okay?
Determine.
But anyways,
angle of elevation from the photo.
okay, it's really just a matter of perspective, and those are terms you ought to be familiar with, okay? But just remember, they're always measured from the horizontal. The biggest problem people have with this is they'll accidentally put the angle from the vertical instead of for the horizontal, okay? They're kind of like reference angles. The other thing to note here is that because horizontal is always parallel to horizontal, what do we know about an angle of elevation and an angle of depression in a problem? They're congruent. Do you remember the term for those from geometry?
No.
No, say no.
Wait,
Okay,
wait,
so
wait.
there was
It's
No,
no.
it's way
So
up.
there was the same side ones. With,
Yeah, side angles.
They're not same side,
Okay.
they're
Opposite.
Opposite edges.
Opposite it.
Oof.
say SAS. Yeah, that's
Ah.
SSA.
Side angle
Yeah.
side.
but I
we're
don't
getting
know.
into
Yeah,
congruent
that's-
triangles.
That yeah. We're not
How about
That's in
alternate?
Interior.
Yeah, there we go.
Yes.
All right, look. They're between the two parallel lines on opposite sides of the transversal, so they are alternate interior angles and they're always going to be congruent.
What were the ones where it was like one on the outside and then the middle one?
Corresponding,
Yeah.
like if I had this angle and this
Yeah.
angle,
Yeah.
they're both to the bottom left of the intersection.
I love that.
Yeah.
That was the best.
Anyways,
You can also get them from vertical angles with the.
you can get vertical angles too and all that too. So, all right, but those are just some terms that you need to be familiar with, okay? But let's look at some applications here. One kind of category of applications is when we're dealing with problems involving right triangles. We're going to use right triangle trig. So here's an example where we have this rescue ladder on a fire truck. Okay. The ladder itself only extends to 110 feet long. Okay, so we've got this ladder that goes 110 feet long. And the common misconception is, oh, well now they can reach 110 feet up the building. All right. The only way they could do that is if they laid it flat against the building, and then no one's going to be able to climb it. Okay.
Oh, that's not true.
So we have safety guidelines. What's the maximum angle that we can safely, climb this ladder, or more importantly, climb down with somebody over our shoulder or something like that if we're a fireman. Okay, and we're at 72 degrees. That's our maximum angle of elevation.
Do they measure that?
Okay, well probably the truck won't let it go any
Oh.
further up.
You
Good.
probably. Just ask him about. Never mind. Just
Yeah.
continue.
So it's
Anyways, the idea here is though, how far up the building can we actually reach if that's what we've got and we want to stay safe? Well, that we'll label A.
We don't know B though.
We don't know B, and that's okay. So we don't care.
All
right.
Important.
Well, now here's the thing. If we have it completely stretched out, then, and this is 110 feet, B is always going to be the same. Okay, this will maximize it.
So we can pick any number.
All right. Well, no,
No.
it'll be determined, but we just don't have to know it. Okay. All right. So here's the basic idea. We have a right triangle, and we need to use right triangle trig in order to solve for A. So think through it with me here. With our right triangle trig, we had opposites and adjacents and hypotenuse, right?
Right. Okay.
So look at the angle that you're using. Think about what you're trying to find and what you know.
So sine of 72 over
Yeah.
A or
Sine or cosecant.
Sine of 72,
You can use either.
because I'm trying to find the opposite and I know the hypotenuse. So when we think it through, what trig function uses opposite and hypotenuse? It's the sine.
You can also
Okay.
use cosecant.
We could use cosecant, but our calculator doesn't have a cosecant button. Oh, maybe the Inspire does,
That's
but
why it does.
it does. Okay, well,
That's why you buy that.
or you could just punch in the sine and hit 1 over, and you got it.
Yeah.
So,
Exactly. Yeah.
Confident.
This one has it too.
but what do we get then? We multiply both sides by 110, and we get
27.92.
I got 104.6.
what do we get?
Oh,
Are you in radians?
maybe.
Yeah,
That's a
104.6.
possibility.
104.6. That sounds a little better.
Yeah.
Okay.
Halfway there.
104.6. So it can reach a little over 100 feet up the building.
It's not very useful. In
Okay.
these cases.
Well, so if we know, a building has 12 floors and it's about 10 feet per floor, everyone's got to get down to at least the 10th floor.
The Empire
Okay.
State is not fire.
Everyone would be in big trouble.
Yeah.
So, but anyways, that's how high up the building it can reach. Okay.
That's like not that much. That's like
Yeah.
That's about 10 stories,
It is?
maybe,
Okay.
depending on the building, depending on the ceilings inside.
Yeah, story
It's
is
like
about
10 to 12 feet per story. But so that's one. That's kind of a simple example. If you've ever done anything with trig before in a previous math class, chances are you've done problems exactly like this.
Yeah,
Okay.
The shadow.
We can also take situations like this where we're finding a measurement indirectly. Okay? We're finding a measurement. In this case, we've got this factory and we have this huge smokestack on the top. Okay? And rather than just sending some guy to climb it, we want to figure out how tall it is by trig. Okay? So, it says at a point 200 feet from the base of the building. So here's the base of the building. We're standing right here. That's 200 feet away. Says the angle of elevation to the bottom of a smokestack is 35 degrees. So they have 35. That's this little angle right here. As we look up at the bottom of the smokestack. Okay? You can't see that. That says 35 degrees right in here. Okay? So then you have, let's use red. Then it says the angle of elevation to the top of that smokestack is 53 degrees. So this 53 that they have labeled here is this whole angle here going all the way to the top of the smokestack. So you see we have two right triangles that are involved here. Okay, we have this shorter, the shorter right triangle here, and then we have the larger triangle that has S, which is what we're trying to find. Okay, we're trying to find S, the height of the smokestack. Okay, so someone want to raise their hand and tell us how would we approach this? What do you think?
I think to find both and then subtract, it's an 18-degree angle.
Okay, so you're saying find this angle here, it's 18 degrees.
Yeah.
So what would you do with that?
First you can find both separate, and then you can subtract to find the S. Because when you use the red one, you're gonna find the whole S plus A.
Okay, so that would give you S plus A.
And the blue one will give you just A, so you subtract.
Okay, and then you're going to subtract. So now the 8 degrees might be useful later on once we know the law of sines and the law of cosines. But in this case, it's nice to know, but we're not going to be able to use that for anything right now. Okay, how would I figure out A though? Using that 35-degree angle.
If you use sine,
Sine,
Close.
yeah. No, wait. Oh, close.
What?
Tangent.
Tangent. Because A is opposite and the 200 feet is adjacent, right? So it's A over 200.
and you get about 255.49.
Is that what you guys got? Anyone else get that?
Oh, no, sorry. 125.367. That's
Yes,
it.
sir. Thank you.
That one's 53 degrees.
Is that the test?
Okay, so you got this?
No, that's
No, that's a
the
different
that's the
question.
53 degrees one.
Oh, that's the 53
yeah,
degrees
right,
one.
right, wrong. It's
Okay.
125.367.
125.367. So let me, oops. Since we've got it here. You used 53 degrees?
Yeah.
So that's actually what we'll get for S plus A, okay? S plus A over 200 is going to be the tangent of the 53-degree angle. This one, what did you say again? I'm sorry.
125.367.
Is that what you guys got? Listen, all of you need to be doing this on your calculators, okay? You can't be fumbling with your calculator trying to figure out how to use it when it's time to take the test, okay? You gotta know how to use the tools that you're gonna have available, okay? Alright, so using the blue triangle, we're able to find A,
It's up there.
okay? And then we plug that into the red triangle to figure out what S is. We still need to subtract the 125.37.
Wrong number again. That's
That's why everybody needs to be doing this,
No,
okay?
I wrote
Check
my
yourself.
numbers down. And
140.74.
because when you subtract,
140.74.
'cause when you subtract 265, 145, you get 125.37.
You get 125. Yeah, if this was 04 or something like that, so that'd be 0.45.
My bad.
Okay.
It's alright.
So the stack itself, that chimney is about 125 feet tall. Okay, so it's almost as tall as the building itself was. Okay,
It's pretty tall.
that make sense? Yep.
It's not trying to scale.
And there are regulations
About
like that
40
to try to
meters.
get it high enough out of the city and whatnot, so. Alright, does that make sense? We can use combinations of different right triangles within the same situation in order to figure out different values, okay? Alright. Now, two more things here I want to look at. One is another way of writing angles, okay? It's kind of an interesting thing, but it's used in navigation quite a bit. And these are bearings, okay? You'll hear kind of two different terms, and sometimes they're used interchangeably. You might hear headings and bearings. A heading is typically an angle where you have due north and you just measure clockwise from due north. So like that would be a heading of 135 degrees or something like that. Okay? Bearings are a little bit more explicit because there are three parts to a bearing. You have where you're going to start measuring from. Then you have an acute angle. It's always going to be an acute angle. And then you have a direction from, or a direction you're going to draw that angle towards. Okay? So we're coming from south and rotating 35 degrees towards the east. That's what south 35 degrees east means. Okay? North 80 degrees west. We start at north, then we rotate 80 degrees, but we could go either way, but this tells us to go towards the west. So 80 degrees towards the west would be that way and gives us this angle right there. Okay?
And you said from, what did you always say like north or south first and then the direction west or east?
Yes. That's typically how these are given.
I hope this is on the test. Better.
North 45 degrees east. We're going to go due north is where we're starting from. We rotate 45 degrees towards east. Okay? By the way, this, we could, because it's a perfect 45 degrees, we could just call that northeast if we wanted to. Anytime you see northeast, they're talking an exact 45 degree angle. Or northwest, or southwest, or southeast. Those are exact 45 degree angles. Okay? Does that make sense? So if I wanted to draw, well, someone give me one.
Like north 25 west.
Okay, north 25 degrees west. So what I would do is I would start out, I always like to draw a little crosshair to start with. And then I'm going to go from the north. So there's due north. I'm going to rotate 25 degrees towards west. Now west is to the left. So 25 degrees this way is going to give me this direction right there. Okay?
So that's like, if you were the origin is,
Uh-huh.
you're gonna, and you have to be facing north and you.
Yeah, you would face north, turn 25 degrees to the west, and walk in a straight line that way. Yeah, Alex?
How are these like applicable?
They're used in navigation all the time, actually.
Compasses, yeah.
Yeah, on compasses. Some compasses will give you like a full 360-degree heading. Others,
Yeah,
you know,
the
you'll
iPhone
see this.
iPhone compass gives you
Okay. Yes.
Can you please put this on the test? Please.
All right. If we don't see it this test, we are going to see it quite a bit through the next 3 chapters of trig we do. So, but, so let's take a look at an example problem that uses these, and the book actually gave us a picture, but let's make our own. Okay. It says a ship leaves port at noon and heads due west at 20 knots, or that's a speed of 20 nautical miles per hour.
That's fast.
Okay, at 2 p.m., the ship changes course to north 54 degrees west, as shown in the picture I didn't put up here for you. Okay, find the ship's bearing and distance from the port of departure at 3 p.m. Okay, so we've got a few different things that we've got to work out here. First of all, let's put our port here. I'm going to label that P for port, and it says that we're going. At noon we leave and we go due west, so that's this way. And that's going to be at a perfect right angle because it's due west. 20 nautical miles per hour, and then at 2 p.m. we change course. So let's say we're changing course here. How far did we travel?
20 miles. 2
2
p.m. to 3 p.m. Oh, wait.
From noon to 2,
Oh, to 40.
40 miles, okay? 40 nautical miles.
Why is it nautical? I'm sorry.
Okay.
Stupid question.
What?
I'm sorry, it's a stupid question, but why is it nautical miles?
Because it's a boat.
Okay.
I don't. That's the unit they use. I mean, I don't even know exactly how that's measured, but
Is it not the same as a mile?
not exactly. It's some. It has to do with some
Look it up.
the way they measure it or something like that. But you guys can look that up tonight or something. All right. So now we're changing our course, and we want to change it to north 54 degrees west. So here's due north. I'm going 54 degrees to the west.
You're 20 miles.
Okay, so there, and it's 20 miles because we changed course at 2 and we wanted to figure out where we were at 3, right? So that's only 1 hour, so that's 20 miles. Okay, so this is where we ended up. So if you look at what they're asking us for, they're asking us for the bearing and distance. So in other words, we need to draw straight line. They want how far that is, and then also we need to figure out the bearing. That's this angle right here. So we know it's going to be north something west, right?
Yeah.
We just need to figure out what that angle is.
Could we cut it into 2 triangles?
Okay? We are going to need to cut this into 2 triangles here. Okay? We're going to make a right triangle here using this. And then we're going to look at the entire thing as one big triangle. Okay? So try to think that through. You've got some measurements in there.
That's 54, not 53.
Yeah, 54. Okay? Just to kind of get us on the right track. What's this angle right here?
46? No, 36.
36. How do we know it's 36?
It's a
90
90
subtract
degree angle.
Yeah, this right here, the 54 all the way down to due west is a 90-degree angle, so we subtract and we get 36 degrees. Okay? So take it from there, take a minute or two. If you want to confer with a neighbor, you can.
So the bearing is 36, right?
No, the bearing that we're looking for is actually this angle over here.
Oh,
Because we want the bearing from the port,
oh,
so from over here.
Can we use Pythagorean theorem?
Yes, you can.
Yeah, sure.
Eventually you can.
I also confused how the right triangle that we drew, how that helps us.
Well,
You know together.
for one, I mean,
You know together.
here's the basic thing we're looking at. You know, to get the whole length of this big triangle, we're gonna need to figure out this little side here, right?
Why do we want the whole length of the big one? So we can.
Well, because we need the hypotenuse,
Okay,
and we also need this angle so we can subtract it from 90 to get this angle. To get our bearing. Okay?
Yeah.
So we need to figure that out. We're also gonna need to figure out this side here. We'll call it Y. And that 20, I'll scooch the 20 over there. The 20 is that blue side there.
Yeah, he went in a big number. I'm really sorry.
Are you sure? Are you confused?
I'm using, I have to use the degrees.
Are you using Pythagorean theorem or something?
Well, no, like, so I keep on getting y is 11.7557.
Anyone else get Y yet?
Which one's? Yeah, I got one.
11 point.
New side.
7557.
Oh.
776. And then I use Pythagorean theorem.
54 degrees.
Okay, so let's talk through this. We did sine of 36 equals Y over 20.
Yes.
I think it's 10.
Okay.
there we go.
No, it's
Did you find X already?
I found X and I added that to 40 and then
What you get x as?
27.
14.4.
Yeah, see, I'm getting x is 261.702.
Now, did you use cosine of 36? Well, did you know Y already?
Wait, what's the answer to that?
Alright, let's work through this.
Yeah.
Okay.
Oh, I'm not lying.
Oh, the big confusion.
Alright, if I'm finding X, I'm going to use the cosine of 36. And that's going to equal X over 20, right? Looking at this little red triangle here. Cosine's the adjacent, 20 would be the hypotenuse.
And you get 16.20.
16.03,
18.
18.
Yeah.
Okay.
When I do Pythagorean theorem using 11.76, I get a massive number.
Did you square root it?
Yeah. Oh no. There we go. Okay.
This is.
Okay. So then to find Y, you could use Pythagorean theorem, or you could do the sine of 36 equals Y over 20. And that would give you Y equal to, I think 11 point, that was in the right ballpark, is that right?
Yeah.
Okay.
Yeah.
And so like that.
Okay. Now let's let everyone, does everyone see how we got those two values? Okay? So, now that we know that, since we know X, we know this whole side now is 40 plus the 16.18. So that's 56.18. Okay?
Sorry.
56.18. And now we know two sides of that large green,
Okay.
as I have it, the large green right triangle, because that's a right angle. So we can get this side here, we can get this angle here, and then subtract 90 to get our bearing.
The angle. Do you want the angle or?
54, right? The bearing.
What'd you guys get for the angle?
You mean the small angle?
Yeah, this little angle here. What would I use to find this little angle? I'm gonna call it theta. I know opposite and I know adjacent
Tangent for
tangent.
Use inverse
You
tangent.
have to find that,
Yeah,
but we know the 54 angle that lies parallel to that foot.
well, it's not parallel actually, because look, parallel, they wouldn't intersect up here,
Oh,
right?
oh,
So we gotta do tangent equal to 11.76 over 56.18. And then you hit
Inverse tangent.
inverse tangent, second tangent on your calculator.
And you get, but it's in radians.
Okay, so convert to rate.
I don't think I can do it on this.
It can,
You can?
actually.
I don't know how.
Oh wait, actually converting.
It's like a swap between the two. I don't know how to convert between the two.
Let me see. Oh. I think you gotta go. I'll have to find it. I thought you could just put the degree sign, but it actually treated that as degrees and converted it to radians again. So it's
Maybe
good
you
at going
could,
that way, it doesn't like going the other way.
Oh, really?
I know you can do it, I just have to look it up. Alright, so guys, what do we get for our distance here? Ellie?
57 point.
What'd you,
57.4.
57.4? Okay. So we ended up 57.4 nautical miles away from the start. Okay. Yes, we actually went 60 nautical miles, but we didn't go in a straight line. Okay. So if we had gone in a straight line, we would have only had to go 57.4 nautical miles. And then here, what'd you do when you got inverse tangent?
Well, in radians it's 0.206.
Okay. Does anyone have that in degrees? You have it?
I'm not sure I'm at 11.82.
That sounds familiar. 11.8? Anyone else get 11.8?
yeah, I got it.
Okay. So this right here is 11.8. So the bearing that we're going to take is going to be 90 minus that, right?
78.2.
So 78.2. So we're going north 78.2 degrees west for 57.4 nautical miles.
It'd be faster to
Okay. What do you mean?
It'd be faster to go.
Yeah, it'd be faster if we went that direction. It'd take a little less than 3 hours. Or if we knew that was the path that a boat had taken and it was disappeared, then that's probably where we would start our search. You know, something like that. Okay? So, any questions about these? It's just, again, it's another way of drawing an angle, or measuring an angle, I should say. Alright, the last application here, this is not something you have to memorize, but it's just something we're going to explore, kind of like the last one we did on the homework. Harmonic motion. What are we talking about with harmonic motion?
If you're playing like a note, the wave that comes out.
Okay, it has to do with a wave. If you see anything kind of vibrating in place, like if you've ever seen a slow motion view of like the top of a drum, or maybe a
Symbol, like.
yeah, you could do that too, or even just if you drop something in the water and you see the ripples start to flow, you have this harmonic motion. All right. Now, obviously, in real life, you know, a lot of times the motion starts strong and then it kind of fades off, you know, until finally it settles down again. Okay? It's possible to graph those, and that's actually in your book. We're not going to spend the time to look at it. We're going to look at ones that, at least for the time, if you look at it for a short period of time, you can consider it as though it doesn't fade like this. We're just going to consider simple harmonic motion that just continues, perpetually. One example of this too would be like if you pulled down on something that was attached to a spring. You know, here's our spring, and we got this little weight on the end of it. Okay, if we pull it down, it'll stretch, and then it'll bounce back up, and then it'll bounce down, and then go back up. Okay, and obviously you know that that would stop eventually, but in simple harmonic motion, we would just look at it kind of perpetually moving that way. So let's look at the formulas. These aren't formulas you need to memorize, okay, so don't worry about that. But we have our displacement, in other words, either going up from where we started or down from where we started. That displacement is going to equal A times the sine of, that's an omega, omega t, or D equals the cosine of omega t. And basically it's, did we start at the midline or did we start up and then drop? Okay, so like cosine would be like if we were looking at the fall of a bungee jumper. He starts at the top and drops and then bounces up and then, okay, we got that harmonic motion. Sine would be something like water. Something drops into it and all of a sudden it jumps up and starts rippling, okay? So you can look at it using sine or cosine. Now, they threw an omega in there, and that's okay. What is omega in relationship to what we've already dealt with? It's related to our period. It's B, right? It's just B. Okay? RB is omega in this context. Doesn't matter what we call it, it still does the same thing. It affects the period.
So this is how you can get D.
So this is how we can get the displacement, how far above or below the resting position we're
So
at.
could we use this in like, if they give us an equation and they ask us to solve for D, like if they give us.
Oh, no, this is not D, a vertical shift. This is
Okay.
a different context here. Okay. Now here, the only thing that we're really doing differently here is identifying not just the amplitude and period, okay, but we're identifying a frequency. And you'll notice here, frequency is the reciprocal of the period. Okay? So, take a look at the example here. And this will be some good practice with our unit circle as well, because you can actually do all of this in your head. Okay, so let's think it through. We have this harmonic motion, D equals 6 cosine of 3 pi over 4 times t.
Isn't that 125? No, 135 degrees.
It'd be 135, yeah. So A, what's the maximum displacement? In other words, what's the maximum value of D? What?
6.
Why do you say 6? Okay, the amplitude's going to be 6.
So it'll be 12.
Well, it's gonna be 6. Well, because there's no vertical shift.
We're going to start up here, okay, because it's a cosine. It starts at the top. It's going to drop 6, then go down 6, and then go up to 0 and end up back up here at 6, right? So you're right, the maximum displacement equals 6. Now question, when is that going to happen? When cosine equals
0. No, sorry, 1.
1, where does cosine equal 1? 0, and also
What's it called? 60. No.
2 pi.
Yeah,
Okay, so here's time 0, because for this whole thing to equal 0, t has to equal 0. And then when this equals 2 pi, alright, so what would t have to be in order for this to equal 2 pi?
would have to be like 2.25, 2.2.
It's too hard. 2.2 thirds. 2 2/3.
No.
Yeah, 2 2/3.
I want-
8/3.
Give him a cupcake.
I want 3 pi over 4 times t to equal 2 pi.
8/3.
I give him an because like
8/3.
2/3 pi.
It'd be 8/3. You're right. 8 over 3. Okay.
It's okay.
So this is when t equals 8/3. Okay. So
And then half of that.
what else does that tell us then? What is that 8/3?
The period.
That's our period. Okay. That's our period. Yeah, Alex?
Is A always the maximum displacement? Is A.
Unless you have a vertical shift, yeah. Okay. Which on these we don't really have a vertical
It would be
shift,
A
so.
plus the vertical shift.
Yeah.
Okay.
Yes.
Sorry, I didn't get how you got that.
Okay. It actually relates to this. It says the period is 2 pi over omega, or remember 2 pi over b is your period. Okay? Well, 2 pi divided by b is 3 pi over 4, or I should say omega is 3 pi over 4. So this is our period.
8 pi over 3 pi.
If I take the reciprocal and multiply, I have 8 pi over 3 pi, and the pi's will cancel, so I have 8 over 3. Alright, so we actually did the period, so what's the frequency?
It's the reciprocal, so 3/8.
3/8. Now what that means is that we're going through one cycle every 3/8 of a unit of time,
We don't know.
because it takes, or I should say, we're going through 3/8 of a cycle every unit of time, I should say. Okay?
Oh. So like every t is 3/8 of the cycle?
Yes, because 8/3 of time is one full cycle. So you divide to get it the other way. Yes?
So. Sorry. What's the frequency then?
If the period is 8/3, the frequency is 3/8. That means we're going through 3/8 of a cycle every unit of time. So, you know, t 8/3 is 2 2/3. So here's 1, 2, 3. Let's say there's seconds. Here's 3/8 of a cycle. Here's 3/8 of a cycle. There's 3/8 of a cycle, which obviously is more than a full cycle now because we've gone past the period. Okay. All right. Now let's think through C and D. Okay. We want the value of D when t equals 4. What are we taking the cosine of if t equals 4?
3 pi.
3 pi, okay? What's the cosine of 3 pi?
Oh.
Question.
That's
You don't need your calculator. Put your calculator down and think.
oh, it's
-1.
2/7.
-1. Why'd you say that, Alexi?
Because it's pi.
It's pi. Coterminal angles, right? Coterminal angles to pi, and then what's cosine of pi? -1. So where are we? If the cosine is -1, our displacement would be -6. Okay? -6. That's going to be our minimum. Alright? In fact, we now know, you know, it's going to be down the way here somewhere. But we know one of these min points is going to be when t equals 4. Okay? I think I skipped a few in there, but at one of those min points, t will equal 4.
How?
Okay. Because we just figured it out. We know that we know that when t is 4, the cosine equals -1 times 6 is -6. So I know it'll be -6
It's
when t is 4.
that's actually right.
Oh, yeah, 3
Or you put it that way.
Okay.
Because it's 2.5.
Oh, I got it right?
It's 2.5
cool.
cycles.
Okay.
Or no, that's one more over.
Yeah, one more.
One more over? Alright, well, it's over here. Okay. Yeah.
Can I go to the restroom?
Alright, then what's the least positive value of t for which d equals 0? In other words, hey, where's this point right here? Now think, if I want d to equal 0, what has to equal 0?
Cosine.
Cosine. So, where is cosine 0?
At
At
degree.
pi over 2 and 3 pi over
Yeah.
At pi over 2 and 3 pi over 2. Which one of those comes first?
pi over 2.
Pi over 2. So, think about it. We want, in order to get this point, we want the angle to be pi over 2. Well, what's the angle?
90.
No, in our model, the angle we're taking the cosine of is that, right?
So make that equal to pi over
So make that equal pi over 2. Alright? And what do you get?
You get, well, you get
3,
what?
3, no,
No, I got 0.
sorry, I was flipping the wrong one.
2 over 3.
2 over 3, 2/3.
Oh, I did 2.
2/3.
Oh, yeah.
Okay? You flip the 4 halves, or the 3 pi over 4, and make it 4 over 3 pi, and then you cancel out, and you get 2/3. Okay? So again, my goal here is not that you'll fully understand harmonic motion, but my goal is that you'll be able to take any formula, pick out key facts about it, and be able to interpret it in terms of the whole process. Okay? Now, we spent more time than I wanted to with me doing stuff, or us doing stuff as a collective. Alright? What I want to do at this point is give you guys the opportunity to work together, working through some practical problems, okay?
I'm back.
Different situations, alright? So, this is just basic solving right triangles. If you're still struggling with that, you can work on that. The rest of these, though, are what I want you to work on as a group, okay? And we've got 6, 9, 12, 13, 14. So we could get in pairs or groups of 3, no more than 3 in a group. Move your desks together, and I want you to work on some of these. Make sure you're labeling stuff. Draw a good picture to go with it, or if you're given a picture, copy it so you can label stuff in it. All right, and that'll help you. All right, so let's go ahead and start that.